This is lesson 11-1 in pre-algebra, graphing linear equations. It says, the graph of a linear equation is a straight line. That's why it's called linear. See the word line at the beginning of that. The line shown is the graph of y equals 3/2 x plus 1. All the points on the line are solutions of the equation, so there are infinitely many points because that line goes on forever. For this line, each time the x value increases by 2, the y value increases by 3. So let's say we started here, over 2, up 3. Okay, over 2, up 3. That keeps happening. If a constant change in the x values corresponds to a constant change in the y values, then the graph must be a straight line, and the equation therefore must be linear. The points in the table below are solutions of the equation. Now this is a different equation. Y equals 3x minus 4. Since a constant change in the x values corresponds to a constant change in the y values, the equation y equals 3x minus 4 is a linear equation, and its graph will be a straight line. The x's are going up by 1, and the y's are going up by 3. That's a constant change because it keeps being the same. Over here, we've got y equals 3x squared. And it says, since a constant change in the x values, up 1, up 1, up 1, up 1, does not correspond to a constant change in the y values, minus 9, minus 3, plus 9, that's not constant. The equation y equals 3x squared is not a linear equation, and its graph would not be a straight line. A real good clue for that, guys, is if the variable is squared, it's not going to be linear. Okay, so now our directions say each table has solutions to the equation below it. Indicate the changes in the x values and in the y values and tell if the thing is linear. So these are going up by 1. So we have a constant change in the x values, but this goes up 2, up 2, up 2, up 2. Okay, so that actually also is constant, and therefore this equation y equals 2x minus 5, that's what we would use to generate these. It's basically a t-table on its side. So that is a linear equation. Now over here we've got plus 1, plus 1, plus 1, but here we've got plus 14, plus 2, plus 2, plus 14. That is not constant. So y equals 2x cubed, which can be used to generate that, is not a linear equation. And you should be able to tell that because you see that this x has been cubed. If x has been cubed or squared, it's not going to be a linear equation. Okay, the next problem says, to graph a linear equation, make a table of values. Choose some convenient x values, ones that are easy to deal with, and substitute each x value into the equation to find the corresponding y value. And here is our equation. I wish they had written that. It's y equals 1/2 x plus, or I'm sorry, minus 3. Now this is just a glorified t-table here. We've got our x value and we've got our y value. That's what you would put in the t-table. But some people need to show a little more work when the equation is a little bit complicated. So they're saying, let's plug in -4, and they picked that because it cancels nicely with the 1/2. So they just plugged in -4 in place of the x right here. So then when you multiply 1/2 times 4, that's -2. That makes -2 minus 3 equals -5. And then they get the ordered pair, -4, -5 from that. Then they picked -2 to plug in. Again, it cancels nicely with the 1/2. Plug in -2 where the x was. 1/2 times -2 is -1. Minus 3 is -4. And then that gives us this ordered pair. And same thing with 0 and 6. Plug in for the x, and it generates a y, which then gives you an ordered pair. So then you use those ordered pairs to graph the line. Starting at the origin, first ordered pair, -4, -5, right here. Next ordered pair, -2, -4. Then 0, -3, and 6, 0. Notice that this particular graph is marked off so that each line adds 2, and that can sometimes be confusing. You need to pay attention to that. So then you connect these lines, and they should indeed be in a straight line, and you put an arrow on each end, and write the equation in there, and you have graphed a linear equation. Okay, now we're going to complete the table ourselves this time for this linear equation. You see how they took the 3x plus 1, or minus 1, and put it right there. They gave us some values to plug in for x. Since there's no fraction this time, anything will do pretty much. So we plug in the -2 in the place of x here. We're going to plug in 0 in the place of x there. The 1 goes there, and the 3 goes there. Then we evaluate each thing. 3 times -2 is -6, minus 1 is -7. And there's our ordered pair. 3 times 0 is 0, minus 1 is -1. 3 times 1 is 3, minus 1 is 2. And 3 times 3 is 9, minus 1 is 8. And then we go ahead and use these ordered pairs to graph our line. -2, 7. Again, we're going by 2's here. 0, -1. 1, oh, whoops, 1, 2. I think I got something wrong there. 3, -. Okay, since I don't want to start over, I'm just going to leave my mistake in there. I figured it out. This should be -7. So I'm going to get rid of this first point that I put on here. Sorry about that. -2, -7 takes us down there. I knew I made a mistake because they weren't all in a line. Okay, and I got that one and that one, so let's do 3/8. Over 3, up 8. And then you connect them all, and if I had a straight edge, that'd be good. And put your arrows on the end.